it's nice because you get a solution. And it's one of those where you can test it. If you've got a solution, you can test it.
I remember
Mhm.
seeing this in high school and hated it.
Yeah.
They just didn't teach it good.
Yeah. Okay. Video's going. Guys, give me just a second. I'm going to get this YouTube stuff situated, and then we will get rocking and rolling. Again, I know you've heard me say it like 7 times now. Your final will be actually, yeah, tomorrow we're going to review for the test 5. Let's start there. Tomorrow we'll review for test 5. So if you have a question, if something's not making sense, please just send it to me and I can go over it in tomorrow's video. Also, test 5 will be open until the Tuesday of Thanksgiving break. I've got to remember to do that today just to get it all set up. And then what else? So then we get back, we'll have a week. We've got to go over a few topics that aren't going to be on a regular test. And then the final, of course, will be that Friday all day. The test will just open up. You can take it whenever you want to. It's 2.5 hours. If you can't make it on that Friday, please get in touch with me because I have to make accommodations ASAP because this isn't a test that you can take late. It's not set up like that unless something crazy happens. Okay. Let's get going. So today we're going to go over 4.4. What's nice about 4.4 is its equations. Everything in 4.2 and 4.3 have been on simplifying, right? This was all simplifying, and we'll see some simplifying concepts in the solving section. But what's nice is we can get an answer and we can check it. Now, I'll tell you, we're going to solve exponential equations and we're going to solve logarithmic. Exponential, you don't have to check it if you don't want to. If you're confident and you feel like you know what you got it right, that's fine. Logarithm, though, when we get to that, we have to check it. So you'll see, I'll get us kind of in the habit of checking these as we go, and some are very easy to check, okay, and some not so much. Okay, so let's talk about the exponentials first. This does have my favorite picture in the entire book on page 479. The elderly couple on the jet ski. Okay, so first we're going to solve exponentials. Exponential equations. I spelled that wrong. That's okay. Okay, exponential equations. There's 2 ways to solve these. The first way we're only going to use if it's set up like perfectly. Okay, and it not that it rarely happens, it's when it does, it makes it really quick to solve for, and it's when we can get something into the same base. So I'm going to show you this based off examples. It's the easiest way to teach it, but the rule really is if we have some base raised to the n power, we'll put an if statement. If we have some base raised to an n power and that same exact base raised to an n power, then we know m equals n, right? I mean, if these bases are the same, these exponents have to equal each other. And this doesn't happen all the time. We can't necessarily always get the bases the same, but when we do, it makes it really easy. Just set the exponents equal to each other and solve. So the goal here really, if you're going to use this, is that, and if you're going to use the other way we're going to solve for exponentials, you've got to get the terms by themselves on each side, okay? So if we had something, let's do one that's really kind of basic. Let's say 2 to the x minus 32 equals 0. Here's a good example. We've got an exponential, because the x is in the exponent, exponential equation because there's an equal sign, and we're going to solve it. So if we're going to solve this one, the first thing we've got to do is move this 32 over. We have to get the exponent equal to hopefully another exponential equation or exponential term. Okay. Yeah. So now to use this property, we're going to see if we can get 32 into a base 2, right? Okay. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2, 32, right? So therefore, we can write 32 as 2 to the 5th power, okay? And if you're like, I don't know that, I don't have that memorized. Well, just use whatever base is over here and see if you can multiply it by itself until you get the number to the right, okay? That's pretty much just how you do it. And then we know, hey, look, if the bases are equal to each other, we can set them equal to each other. Well, x just equals 5, right? And again, again, I'm going to get in the habit of checking it. Let's use another color to check it. Go pink and green, 90s flavor. So we're going to check x equals 5 here. I'm going to pop it into the original. So this is just me checking over here, okay? So 2 to the 5th minus 32. I want to know, is this equal to 0, right? Oh, yeah, we just said 2 to the 5th is 32. 32 minus 32. Remember, if you subtract anything from itself, you always get 0. So it checks out, okay? X equals 5 is our solution. So, hey, look, that's nice. Look, this one was really easy to check. If they're a nice integer, why not check them, okay? And then you'll get that answer right on the test. You'll be happy. I'll be happy. We'll all be happy. Your parents will be happy, okay? Questions? Make sense? It's not too bad. So let's do one that's kind of kicked up a little bit, where we have to really think about it. And you'll notice this has similarities to the last section we went over. So let's say I'm going to steal one. This is number 14 in the book on page 489. It says 5 to the 2 minus x equals 1 over 125. Okay. Now remember, so I'm going to try to use this same base. And my indicator is I know I can multiply 5s and eventually get a 125, right? 5 times 5 is 25 times 5 is 125. So before I get started, I'm going to rewrite this as 5 to the negative 3. I'm sorry, 5 to the 3, and then I'll move it up. So it's 5 to the 2 minus x over 1 equals 1 over 5 cubed, right? And then from the last section, we know, I mean, actually from the exponential section in a previous math class you've taken, we can move this 5 to the 3rd up by making it negative. All right, so we manipulated this fraction. 1 over 125 is really 5 to the negative 3. We saw that, I believe, I think it was the last section. I think it's 1.3. And now look, we've got the same base. We can set these equal to each other. 2 minus x equals negative 3. And then just solve it out. So subtract the 2. We get negative x equals negative 5. Divide by negative 1. We wind up with x equals 5. Okay? Let's see if that works. Again, I'm going to check these every single time. Okay? So I'm going to go plug this one up in the top. So 5 raised to the 2 minus 5. I want to know, is that equal to 1 over 125? So we get 5 to the negative 3. Now we know that's 1 over 25, but I want to show you, I don't think I've gone over a button in the calculator that gives us fractions, which is super cool. If I put that left, 5 to the negative 3, so 5 raised to the negative 3 power, I get out of the exponent. If I hit the math button, see that math button under the alpha? Did you get 5 to the negative 3 in there? Okay, hit the math button and then hit enter. It'll give you a fraction answer, which is awesome. So 1 over 125. Okay, so we know that this matches up. We got the right answer. We know x equals 5 is the solution. Okay, so it's kind of nice. That's handy. That fraction button comes in handy, especially whenever we have fractions going on everywhere. Okay, questions? It's not too bad. Let's do one. Ooh, yeah, okay. I'll tell you, when these look harder, I'm going to automatically do the next way of solving, because the next way is one of those kind of formulaic ways that fix answers it no matter what. Okay, you can use this next way on all the ones we've done so far, the 2 we've done so far. It's not a big deal. It's just this is nice when you see it. It really does take less time when you see it. Okay, let's do one more. This is 22, just to show that it can be done a little differently. We've got e to the x plus 4 equals 1 over e to the 2x. This is 22 on page 490. Okay, let's see here. Well, we know e is going to be the base, so we don't have to worry about manipulating bases, but we do need to get this to move to the top, right? We got to get this moved up here. So remember, to do that, we just set the exponent negative. So it's going to be negative 2x. Hey, then we could set those equal to each other. Okay. Then we just have to do some basic solving. Move the x's to one side. And then that would be what, negative 3x. And then negative 4/3 equals x. I'm not going to check this one just because I want to keep moving on and keep pushing forward. Okay. But if you put negative 4/3 in here, you'll see negative 4/3 plus 4. And then this would be 8, negative 8/3. Yeah, it'll work out. Okay. I know that's the answer. It's the answer in the book. I cheated. Okay. Okay, let's get to the other way of solving these. When maybe we can't get the bases to look the same or to manipulate into the same base. So let's say we had one very blatant that we can't do. Let's say we had like 2 to the x equals 5. Okay, 2 to the x equals 5. Okay. If we want to solve this one, we can use the property of the power rule of the property. Okay. Now we have to get, just like before, we have to get, it's a term, term equals a term. But we can use the power rule with a common logarithm. I'm going to use ln. So what I'm going to do is I'm going to take ln of both sides. And it's an equation, right? Make sure you take it on both sides. And then in doing this, I've got this x and the exponent inside a logarithm. I can bring it out front, okay? So it winds up being x ln of 2 equals ln of 5, okay? Pretty smooth, right? This is a smooth trick on how to get an exponent, or really an exponent out of the exponent, is just take the ln of both sides and it can pop out. Now, we're solving for x, so we've got to divide by ln of 2. So we get x equals ln of 5 over ln of 2. Now, your book, okay, let's see what it says here. Express the solutions set in terms of natural logarithms or common logarithms. We did that. Then use a calculator to obtain a decimal approximation. Okay, so let's obtain a decimal approximation here. Let's see. So, I'm going to calculator up. I'm going to say ln of 5 divided by ln of 2. There we go. Now, this is an approximation. It's about 2.3219. I'll do 4 decimal places. Okay, 2.3219. Make sure to close parentheses there. ln 5, close parentheses, divided by ln 2, close parentheses. And now I'm going to check this one just to make sure we're right. So I'm going to take this, plug it back in. Now, look, we rounded. It's an approximation. The squiggle lines mean approximately, okay? So we're going to take this 2.3219 and plug it in here. And I'm going to see if it's about 5, okay? So 2 raised to the 2.3219. Oh, yeah, that's pretty close, right? 4.9999999. Okay, so it checks out. And so what that means, now it depends on how the book answers it. I'm going to tell you on the test, it's either going to put it as ln 5 over ln 2, or it's going to put it as a decimal approximation, okay? So either one. So make sure, and your homework does this too. It asks you to solve it both ways. So just be ready and prepared to answer it either way, okay? Either way is fine. It's not a big deal. Okay? Questions? No, it's pretty good. I mean, it's pretty straightforward. Let me give you one just to try. Nah. We'll keep going. You'll just try it on the homework. Let's do one with a base e. If it's a base e, it's nice because ln and e cancel each other out. I'm gonna steal one from your book. Let's say this is number 90 or number 30 in your book. Number 30 says 9 e to the x equals 107. 9 e to the x equals 107. So if I want to solve for this one, same thing as before. I've got to get the exponent by itself, so that 9's got to go away, okay? So I've got to divide the 9 on both sides. This is not going to divide out nicely, which would have been nice. So I'm going to leave it as 107 over 9. It doesn't divide evenly. It's like some decimal, so I'm not worried about it. Okay, I'll leave it as 107/9. And now look, just like before, look, I can't get this into a base E, so I can't use the first way of solving. I'm going to take the ln of both sides. Be careful. The most common mistake is us not taking the ln of both sides, only doing it to the left because we see that the x needs to come out. Okay, so ln of e to the x equals ln of 107/9. Now look, guys, check this out. This is cool. The ln and the e cancel each other out, right? Ln is log base e, so this just goes away. It leaves you with x. Okay, leaves us with x, which is pretty cool. So this is one of the ways to answer it. This is actually the exact answer. The other way is going to be with an approximation. So now this one, the 107 is divided by 9 inside the logarithm. So it's 2.4756. Okay, that's not too far off from our last answer. That's kind of crazy. But again, I'm going to check it. I'm going to say 9e to the 2.4756. Now I want to know, is that close to 107? Remember, that's what we started with. That was our first, the equation up there. So 9, you guys see that 9e. So 9e. If you got the other calculators, it's like, does a parentheses, right? There's a character parentheses, yeah. As long as you close that parentheses, you're fine. Not 2.4756. Oh, yeah, 106.9995. Yeah, I'll take that. That's close to 107, right? That works. So we're going to box in whichever one they ask for, which on the homework, they're going to ask for both. So we're going to box in both for now. Okay, on the test, it'll be either or. It'll be either a decimal or the logarithm. Okay. Okay, yeah. Let's do one that kind of takes. We're gonna kick some up a notch. Okay, this can happen every now and then, where it just takes a little more time. Do they do it with a? They don't do it with a number. They only do it with. Okay, that's fine. So let's look at 36. So 36 says e to the 4x minus 5. So that's the exponent. Where am I at? 36. Yeah. Minus 7. Now the minus 7 is not in the exponent. Equals 11,243. Okay. Now I'm going to put little parentheses here because I know that's what's in the exponent. And we're going to solve this out. Now look, just like before, we have to have this by itself. So I'm going to add the 7 over. So we get e to the 4x minus 5 equals 11,250. Okay. And then just like before, I'm going to take the ln of both sides. Okay. And just like before, now what's different on this one is, actually what's nice is the ln and the e cancel, right? It's not that the 4x minus e goes out front, which it does. It leaves you with ln and e, and that goes to 1. So it's two ways to think about it. But this cancels, and it leaves us with 4x minus 5 equals ln 11,250. Now I got to get to x, right? And everything we do after this is not going to be inside the logarithm. So I'm going to add the 5, divide the 4. So add the 5. Can't add it inside the logarithm. So it's just going to be on the outside. And then divide everything by 4. So divide the whole thing by 4. And then we wind up, this is our solution, hopefully. I mean, we'll check it. Hopefully it's our solution. So on we get, do parentheses for the entire numerator. Okay, that's my numerator. ln 11250, close that set of parentheses because that's the parentheses for my ln 11250. Is that right? Yep. And then plus 5. Okay, close that set. So now that's my entire numerator, right? And then I'm going to divide by 4. 3.5820. 5820, yeah. Hopefully that's the answer. I shouldn't have boxed it in. That was too confident of me, okay? But I'm going to check it now up here. So I'm just going to do this in my calculator instead of writing it on paper. I'm going to just pop this left-hand side in and see if I get something really close to 11,243. Of course, it's not going to be 11,243 because we rounded here, okay? So I'm going to do E raised to the 4 times 3.5820 minus 5, right? That's all in the exponent there. Oh, there you go. That's all in the exponent. 4 times, see that 4 times 3.5820 minus 5. Okay, let me go back to here now. And then I've got to, not do that. I got to come out of the exponent and put minus 7. 11241. Yeah. Now this is close enough for me. Okay. And it's the rounding aspect is what's causing this. So we're good. If I wound up with like 28 million, that's when I know I'm wrong. Or, 5, something like that is when that's the indicator when, okay, I'm not right. Okay. I checked out. Awesome. Yay, the crowd is wild. Okay. Questions? Okay, buckle up. This next one is going to take a little bit of time and energy, but we've got to go over it. So this is actually, I'm going to use one from the previous section. It's, I don't know, I saw it. Did I see it? Oh, yeah. This is number 20. Okay, number 20. I might need a new marker. And it says 8 to the 1 minus x equals 4 to the x plus 2. Marker's got to go. 8 to the 1 minus x equals 4 to the x minus 2. Now, I'm going to be careful here. Keep up with those parentheses, my exponents. Okay, so I'm going to take a look. This time I've got an exponential term on the left and the right. These don't match. These bases don't match. I can't multiply 4s to get 8, right? 4 times 4 is 16. I know your brain's going, but 4 times 2 is 8. And you're right, 4 times 2 is 8. But you remember you have to multiply by itself to get that bigger base, okay? So I'm going to do the same thing I've done so far. I'm going to take the ln of both sides. Okay? Now really, this whole thing is inside the ln, right? And this whole thing is inside the ln. And the whole reason we take the ln is to get these exponents moved to the front. So 1 minus x comes to the front. And you're left with ln 8. X plus 2 comes to the front. And you're left with ln 4. Okay. Not a big deal. Now, this is where it's going to take a little bit of time. So there's a few ways to do this. But remember, in the end, let's think back to like 5th grade, 6th grade maybe, when you learn how to solve algebraic equations. The goal was to get all the x's on one side and all the numbers on the other side, right? That was, if we go back basic. Now look, we've got x's over here and we got x's over here. So if we can get rid of the parentheses, we can move all the x's to one side and we'll call them non-x's, okay, to the other side. And that's going to be our goal. And it's going to take us a minute to get there, but that's going to be our goal. So I'm going to distribute the ln 8 to both terms to get rid of the parentheses and the ln 4. 1 times ln 8, that's just ln 8. Minus that, I can't multiply these together, so it just becomes a coefficient, x ln 8, okay? Because you're saying negative x times ln 8. Ln 4 times x, same thing, x ln 4. And then plus 2 ln 4, okay? So we've got rid of the parentheses. And notice, we've got an x here and an x here, right? So I'm going to move the x's to the left. So I'm going to have my two terms with x's on the left side of the equation. And I'm going to move this ln8 over to the right. And I'm going to do this in one step, so I don't have to do two separate steps. So I'm going to move the ln8, so subtract it on both sides. And then I'm going to subtract the x ln4 from both sides. Okay, so look, this ln8 and this ln8, they go away. They're opposites. Now I'm going to just write this out. So I would have negative x ln8 minus x ln4 equals, this went away. So it's going to be 2 ln4 minus ln8. So look, we did what our 5th or 6th grade teacher told us to do. We got all the x's on one side and all the numbers on the other. Now the difference is back in 5th or 6th grade, you could add these together, right? When your x's got on one side, it was like, oh, 2x minus 5x. Oh, it's negative 3x, right? But here we can't. We can't add these. These aren't like terms. ln8 and ln4 you can't add together. But they both contain an x. So what you can do is factor the x out. Okay? And I know what you're thinking. Oh my God, this one's crazy. I told you to buckle up. Okay? I warned you. And now look, it's x times something. Well, let's just divide off that something. And we're left with 8, or we're left with x. I'm going to write this in parentheses as well, because we've got a numerator and denominator. And look, that's what our x value is going to be, hopefully. Okay? I might check it. I might not. I don't know. We'll see. I mean, we're going to pop in the calculator to see what number we get. And I've got to be really careful in the calculator. So I'm going to say parentheses 2 ln4, close that set, minus ln8. Now I got to close the ln and close for the entire numerator. Okay? So I close for the ln and close for the numerator. Divided by, open a set for the denominator, negative. Make sure to use that negative button. Oh wait, you guys can see my finger. Make sure to use that negative button and not the minus sign, because it's going to throw it off. It'll think it just, the way the calculator's programmed, you can't do that. So that is for a negative number. This is for subtraction. So negative ln 8, close that set of parentheses. Now we're doing subtraction, so minus ln 4. Close that 4, close the entire set of parentheses. Math. Oh ho, negative 0.2. That's a sweet number, okay? Because what that tells, because it's either repeating or it stops the decimal, it means I can write that as a nice fraction. So check this out. What you can do to get this into a fraction in this calculator, you just hit math, frac, and it takes the answer and it converts it to a fraction. Negative 1/5. Look at that. All of that for that answer, okay? That's cool. I am totally going to check this now, okay? I'm going to pop negative 1/5 into the left-hand side and see if it equals the right-hand side. So I'm going to say 8 raised to 1 minus. Now, it would be negative 0.2 will be easier to put in the calculator, right? Because remember, as a decimal, it was that. So 8 raised to the 1 minus a negative 0.2, 12.1257. And I want to see, is that going to be equal to, if I do the same thing on the right, 4 raised to the negative 0.2 plus 2? Yeah. 4 raised to the negative 0.2 plus 2. Boom shakalaka. Same answers. Or same numbers, I should say. That checks out. That is my answer. Ooh, I think that's the hardest one. That of all the ones we're going to do today, I think this is the hardest one. We're going to see a more complex logarithm when we get to the solving logarithm questions, but this one just has the most steps, okay? It just kind of keeps going. It's a good challenge question once you get there, okay? Good challenge question once you get there. Okay. Okay, so let's switch gears now and go, okay, what if we wanted to solve logarithms? I think logarithms are a little easier than exponents. The goal with a logarithm is really to put it in exponential form, okay? The goal of a logarithm is going to be to put it in exponential form. So sometimes you can't do that right off the bat, and we'll get to those examples. And sometimes you can. So let's look at some where you can just stick it right into an exponential. Let's say we had log base 4. I'm going to steal this one. Actually, it's one of your homework questions. Actually, let's not do this one because it's one of your homework questions. Let's do an even one. This is number 54. Log base 5 of x minus 7 equals 2. Log base 5 of x minus 7 equals 2. Now, like the exponential equations, we've got to get the logarithm by itself on the left or right, but we've got to get the logarithm by itself. And then we can do whatever we want to with it. Okay. Now we might have to condense it. We'll see that in a few examples. But we have to get the logarithm by itself. So once we have the logarithm equal to some number, all we have to do is to flip this into an exponential equation. Now remember, if this was a logarithm, I start with the base. The base is 5. We'd raise it to whatever's by itself, because remember that was the whole point in doing logarithms, was to get the exponent by itself. It's going to equal whatever is inside the logarithm. So logarithm written as an exponential, 5 squared equals x minus 7. Okay. And then we know 5 squared, that's 25. This turns into really easy stuff. Okay. Add the 7. Okay. 25 plus 7, that's going to be 32. Okay. Hopefully. We're going to check it. But hopefully it's 32. Now, I'll tell you, you have to check logarithms because we cannot have a negative inside the logarithm. Now, we can have a negative answer, okay? We cannot have negatives inside logarithms. So when we check this, we're really checking to see, well, 1, does it make the solution correct? But 2, does it create a negative inside here? And if it does, we have to just toss this answer out, okay? Well, I'll try to get to one that does that. I think towards the end we'll see one. So let's check x equals 32. So log, this marker is about to be out too. Almost the end of the semester. We've almost made it. 32 minus 7. And I want to know, is that equal to 2, right? Well, 32 minus 7 is 25. Now, look, you can do this in your calculator, or you can do this. I'm going to do it in what we learned in 4.2. And remember, 4.2 said if we get this in the same base as our base, which we can, it's 5 squared. These cancel, and it leaves you with the exponent. This checks out, okay? So that means x equals 32 is the solution. Cool. Look, it might have taken longer to check this than to solve it, okay? Which is fine. That's not a big deal. In BD, okay? Okay, let me find one that's a little different, maybe. Or that looks a little different anyway. Oh yeah, let's do one with an ln. Let's say we've got, this is number 62. 6 ln of 2x equals 30. Okay, 6 ln of 2x equals 30. So now, just like before, I got to get this 6 to go away. Okay. Now, I know, hopefully your brain goes, hey, we could put that in the exponent. You can, but it makes it exponentially harder. Yes. Okay. I got to throw that math dad joke in there. So we don't want to put this in here. That makes like 2 to the 6 and x to the 6th. We don't want any of that business. We're going to divide it away to the other side. Okay. So ln of 2x equals 5. It's great that your brain thought, hey, we can do the opposite of what we were doing before, right? I'm glad that you know that rule, but it actually makes it harder if we do that in this situation. So we divide the 6 away, and we get ln of 2x equals 5. Now, you've got to remember, look, we're going to move this one directly into an exponential equation. But you have to remember that ln is really log base e. I'm going to write it out here just to show you what I'm talking about. ln is really log base e. So if I want to write this as an exponential, it's e to the 5th equals 2x, right? E to the 5th equals 2x. Okay, so then we just have to solve for x, so we divide by 2. And we get e to the 5th over 2 equals x. Now, this would be our exact answer. If they ask us for a decimal, which I don't think they do in this section, but we'll see. Well, number 60. This is 62. Solve each logarithmic equation. Be sure to reject any values of x that is not in the domain. That's what's saying about not making it not negative. Give the exact answer. Then, where necessary, use a calculator to obtain a decimal. Okay, so here's the exact answer. This would be considered the exact answer. Let's find the decimal approximation. So e to the 5th, make sure you're out of the exponent, and then divide by 2. So the approximation would be 74.2066. Okay, if we rounded to 4 decimal places. And I'll check this one with that number. Okay, I'm going to go back to the very beginning. I'm going to see if I plug this in, is it going to be close to 30? So it's going to be 6 ln 2 times what we just found, 74.2066. Make sure that's in the ln. Oh yeah, look how close that is to 30. Holy cow, 30.00000. That's close enough. Okay. So depending on what they ask for the approximation, excuse me, or the exact, those are our 2 answers. Okay. Okay, good. I'm going to give you a little quiz now to kind of see where we're at, and then we'll move on. We've got 2 other. I know one other example I want to do in this section, but it's a totally kicked up example. So I want you to try these, and I'm going to mix exponential and logarithm together. Okay, so it's going to be just really like a mini quiz here. Number 1, we'll do 4 to the x equals 32. Number 2, we'll do log base 2 of x plus 1 equals 3. Number 3, we'll do e to the 2x equals 5. I might have done that one already. That's fine. Okay. And then number 4, we'll do, start working on those, and then I'll find a good example. Another good example here. Oh, yeah. No, somewhere. Okay, yeah. Let's do one. Let's say like 6 plus 3 ln of x equals. Hold on, let me see here. Try one that doesn't get a crazy number. Let's say 3. Yeah. This will work out. So try those 4. This will give us kind of a good idea for getting it, and then you kind of work on homework with me, some kind of basic homework with me. Okay, wait, I'm going to add one more. I mean, keep working. I'm going to add one more. So number 5 here. This will be 5. I'm stealing this one straight from the homework. It's number 38. 5 to the x minus 3 equals 137. Okay. I'll give you a few minutes. If you don't get all these done, that's fine, because I do want to get to some really important application examples here in a minute. Okay, you can keep working, Janie, but you can pause this. If you're not done, just pause it and then get done and then come back to it. But I'm going to start on these. So just keep working if you're working, or pause me. And then when you get done, come back. Remember, exponentials, this is set up quite nice. Oh, I can't get 32 to the base 4, can I? So I'm going to take the ln both sides. So ln of 4 to the x and ln of 32. Bring the x out front. So I get x ln 4 equals ln 32. Then divide the ln 4 away. So this would be our exact answer, unless we have a nice fraction, which I think this one makes a nice fraction. ln 32 divided by ln 4. Oh yeah, 2.5. So I'm going to do the math button and then frac. What's that? 5 halves? Yeah, we wind up with 5 halves. I'm not going to check these. You can check them, make sure I'm right. If I'm wrong, email me. Okay. So let's do the next one, logarithm. Okay, so this is set up nice for logarithm too, because all I have to do is put this in exponential. 2 cubed equals x plus 1, right? And 2 cubed is 8. Subtract the 1 away. So I wind up with 7 equals x. 7 plus. Now I am going to check this to make sure I can use the 7. Look, 7 plus 1 right here is 8, so it doesn't make a negative number. It'll be right, because that's 8, 2 cubed equals 8. So it works out. Number 3, okay, now we got an exponential with an e, which is nice. So I'm going to take the ln of both sides. The ln and the e cancel because they're the same base, 2 bases in a way. So we get 2x equals ln 5 divided by 2. Now look, make sure that 2 is not inside the logarithm, okay? That's not a goofy thing. I shouldn't say goofy. It's just an easy mistake. So I'm going to put this in my calculator to get a decimal approximation. So it's going to be ln of 5, divide that. Make sure that parentheses, look, you guys see that parentheses right there? Make sure that you close that parentheses. Because you're dividing the 2 outside of the logarithm, and it gives me 0.8047, okay? So if it asks for an approximation, that's my approximation. Okay, so the one up here, now I've got to get the ln by itself. So I'm going to subtract 6, and I get 3 ln x equals negative 3. Divide the 3 away. I get ln x equals negative 1. Well, that's kind of weird. Okay, that's fine. So now it's an ln, it's a logarithm. So we've got to make this into an exponential. And remember, ln is a base e. So this is really just e to the negative 1 equals x. Kind of cool. Okay. Now, I don't know if they want you to answer like that or 1 over e. Remember, we've talked about how that's the same. That's fine. I'm going to pop it in the calculator just to get an approximation. 0.3679. Which we can put that in the calculator. That's fine, or in the x. It's not a negative. So there's my approximation. There's my exact. Kind of cool, okay? Okay, the last one. Again, it's an exponential, so I'm going to take and it's already by itself, so I'm going to take the ln of both sides. Okay, bring the x minus 5 or x minus 3 out front. Okay, remember that last one that was harder? Remember how it had the other stuff going on the right. It was like x plus, this one doesn't. So because this one doesn't, I'm going to divide the ln 5 away. Okay, so you wind up with x minus 3 equals ln of 137 over ln of 5. And then you just have to add 3 to that. Okay, and that leaves us with our answer. I know I'm zooming through these. It's just to get a few examples in so you can kind of see my steps. Okay, and I'm going to pop this in the calculator. So ln of 137 divided by ln of 5. Notice all that's your calculator knows order of operations. It's going to divide this first, and then it's going to add 3 to the outside, and you wind up with approximately 6.05. 0.070, wasn't it? Yeah. 6.0570. So there's my exact, and there's my approximate. Cool. Okay. That's just a good group of questions for to kind of quiz yourself as you're going. And I'm going to tell you, look, if you don't get these right now, that's fine. Look, these build on themselves, so they get harder as you go. So don't get too upset with yourself if you're not getting it. And also, the sections build on themselves. So if some of this stuff just isn't making sense, it could be that you need to go back and do the homework from the previous sections. Okay, so let's get into the real. Actually, no, I got to do one more, and then we can get into the real examples, which are the fun ones. I've got to do one where it turns into a quadratic, and these are just crazy, but I have been known to put these on the test. Log base 6 of x plus 5. This is number 68. Yep. This is number 68 in your book. So log base 6 of x plus 5 plus log base 6 of x equals 2. Now notice what's different about this one is we've got two logarithms over here, right? Now, what we can do, because they're the same base, we can combine them, right? In 4.3, we learned if we have addition of the same base, we can condense them together. So that's what we're going to do. And now when we condense them, we're going to be multiplying them. Okay? So condensing together means multiplying together. Now, look, I'm going to clean this up a little bit. Look, it's x plus 5 times x. You've got to make sure to distribute the x to both terms in there. So you get x squared plus 5x equals 2, right? Okay, makes sense? So now, look, now we can do what we've been doing so far. It just looks a little different. But we've got a logarithm, the logarithmic equation. So I can make this into an exponent. Look, 6 to the second power equals x squared plus 5x. Oh my God. We've got an equation we've been solving for since, didn't mean to hit the camera. We've got an equation we've been solving for since day one, right? Remember day one, in this class, in college algebra, we reviewed how to solve quadratics. And then we went into how to graph quadratics. And then we went on to how to graph all kinds of stuff, actually other things, and find zeros. This is all, it all ties together here, okay? Now, if I'm going to solve this, remember with a quadratic, I need to get 0 on one side. So I get 0 equals x squared plus 5x minus 36. What's nice about this one, and when you do these in the homework, these will factor. So we get x plus 9, x minus 4, right? Multiplies to give me negative 36, adds to give me a positive 5. Set both of these equal to 0. Okay, and you're going to get all the way to 2 nice answers, and then you're going to pat yourself on the back. You're going to be so excited. You got an answer, and not just an answer, 2 answers. That's awesome. That you're going to forget to check. And these are the ones typically where you can throw out one of the answers, okay? Look, -9 here. If I plug -9, if I want to check this, get the pink marker out. If I want to check -9, it would be log base 6 of -9 plus 5 plus log base 6 of -9. And I want to know, is that equal to 2? I can throw this away right off the bat because you cannot ever have a negative inside a logarithm, okay? I'm not checking it even. And actually, it's -4 right here and -9. So this one just goes away, okay? I'll check 5 though. So let's check 5. And it's a good review from the last section. log base 6 of, oh, how did I say 5? It should be 4. Somebody's yelling at this, been yelling at the screen since I wrote 5 down. So 4. Log base, so I'm going to plug this in up here. So 4 plus 5 is 9. Plus log base 6 of 4. I want to know, is that equal to 2? So remember, with addition, you multiply, right? So this becomes log base 6, 9 times 4, so 36. And I want to know, is this equal to 2? Yeah, it is. Because look, 6 squared equals 2. If we put this into an exponential, it would be true. 6 squared equals 2, so it works out. So 4 is our solution. It's our only solution. And I capped this twice. Where did these caps work for both? Okay. So it's a lot of work. And I'm not expecting you to know this yet. I need you to do the homework up to this point. But I wanted to make sure to do that example. So when you get to the homework, you're not going, oh my God, he only did the easy ones in the homework. Okay, let's do some real life examples. And this is when I get to predict my YouTube fan Riker's height. Okay, hold on. I got to check my email real fast. Because Riker's mom, Megan, sent me his exact age and his exact height. Give me just a second. This is a fun example. Where is this email? Oh, here we go. Here we go. Mr. Riker is 5 years, 11 months. He's got a birthday coming up. 5 years, 11 months, and he's 48 inches tall. Okay, this is what we need. We're going to look at this. I just saw this example. Where did it go? Oh, was it actually in the last section? Did I go? Oh, no, I think it's in the examples. Yeah, it's in the examples. This is example 11 on page 488. Example 11, page 488. And it says f of x equals 29 plus 48.8 log of x plus 1. It says, now I'm going to kind of read it. It says, we have seen that the percentage of adult height attained by a boy who is X years old can be modeled by this. Oh, I must have skipped this example. So we're going to do Riker's example, and then we'll go on to the actual example. So we want to know what percent. So in the question, it actually says, at what age round of the nearest year has a boy attained 85%? We'll get to that. We're going to predict Riker's overall height. Okay. So X is years. Now, the issue with this formula is you have to be between 5 and 15. So if you have a kiddo that's a boy between 5 and 15, you can predict their overall height. You need to know their current height, but they've got to be between 5 and 15. Okay. So we're going to use for Riker, since it's 11 months, now it's 11 out of 12, right? So 0.9, we'll do 0.92. So we'll say Riker is 5.92 years old, okay? And we'll use the 48 inches here in a minute. We want to know what percent of his overall height has he obtained. So we're going to pop 5.92 into this formula. 29 plus 48.8 log of 5.92 plus 1. Okay, that's a log right there. So I'm going to pop it in the formula. So we get 29 plus 48.8 log. Is that right? 48.8. Yeah. Log of 5.92 plus 1. Boom. Riker has obtained, and any boy that's 5 years and 11 months, has obtained 69.9, actually, let's round it to 70. 70% of his adult height. Okay. Riker's obtained 70% of his adult. So he's going to go 30% taller than what he is now, right? So how can we predict his height when he gets taller? Well, I think we did this example with girls, didn't we? Yeah. Okay, good. So what we're going to do is we're going to think of his adult height. We'll use A. His adult height times 0.70, because he's obtained 70%, is going to be 48 inches, right? So divide that by 0.70. So 48 divided by 0.7, 68 inches. Okay, Riker. You are predicted to be 68 and a half inches tall. So that's 5 foot and 8.5 inches is your predicted adult height. Now I'll tell you though, you just never know. You could be shorter than that. You could be taller than that. This is just a model, okay? Because Lord knows with boys, it takes 2 months and you'll be 52 inches instead of 48, and it throws this model completely off. So track that. It's kind of fun doing this. And again, I've done this with my son. I've used this as an example. Holy cow, for like 8 years now. Like it is crazy, and it is tracking my oldest son's height pretty closely. I need to do my youngest son to see where he's at, but I don't know his exact. I do know his exact height right now. I'll do this later on, and see how tall it says he's going to be. Okay, so this is pretty cool. 5 foot 8.5 inches right there. Man, that's tall. It's a lot taller than you are right now. It's 10 inches tall, right? Wait, no. Right now, 48 inches. That's 4 foot, right? Oh my gosh, that's 18 inches taller than what you are right now. That's pretty tall. Okay, so let's get to another example. This is one of my favorite examples in the book as well. And it talks about students forgetting things. This is example 117 and 118 in the book. And you'll need the book for this one. I'll give you the formula. It's okay if you don't have it, but I'll give you the formula. The function p of x equals 95 minus 30 log base 2 of x models the percent of students who can recall the important features of a classroom lecture as a function of time. So percent of students, I'm just going to say percent of students who remember, okay? Just so I don't have to write as much. But it's the percent of students who can recall information after a certain amount of days, and x equals days. Days since the lecture. Okay, days since the lecture. So let's look at 118. 118 says, because I'll do 117 in the homework. After how many days have all the students forgotten the important features of the homework? So let p of x equal 0. It gives you a hint there. Let p of x equal 0. So we want to know how long does it take? How many days after the lecture do no students remember anything from, all the students have forgotten? So p of x equals 0. So if we plug this in the equation, we get 0 equals 95 minus 30 log base 2 of x. And it turns into a nice logarithmic equation, right? A nice real world logarithmic equation. So let's solve this thing. Now, we got to get the log by itself. So we're going to add subtract the 95, divide the negative 30. So I'm going to subtract the 95. We get negative 95 equals negative 30 log base 2 of x. And then we're going to divide the negative 30. And we get, okay, let's just simplify. Look, I'm going to be lazy here. 95 divided by 30, we'll do math. Frac. It's 19/6. So 19/6 equals log base 2 of x, right? Look, two negatives make it positive. 95 divided by 30 just simplifies into 19/6. But now we've got a logarithmic equation that we have earlier. Like this is when we started earlier, right? And now we can write this as an exponential. This would be 2 to the 19/6 equals x, right? So I'm going to pop that in the calculator. 2 raised to the 19/6. And we get roughly 8.9797 days. So I think it asked us to round to the days, maybe. I'm not sure. Round answer to one decimal place. Well, if we round it to one decimal place, it would actually round to 9. So 9.0. So after 9 days, this study has found, after 9 days, everybody's forgotten all the important parts of this lecture, which is kind of crazy. Okay. But telling, I could see that. 9 days, man, that's a lot of sleep, right? Like if I lectured you and you didn't take notes and you didn't go do the homework, right? If all I did was just lecture to you, in 9 days, they're saying you'd forget everything. And what you would remember is the goofy stuff. That is something else if you want to get into like educational research. You'll remember like goofy stuff. Like you'll remember that jelly donut example, right? You won't remember anything about that section. You won't remember that's about composition of functions. And no, none of that. But you'll remember, oh yeah, you talked about jelly donuts. I remember liking that. Yeah, that's what you remember. Okay, let's look at another example. So that was solving a logarithm in the real world. Let's look now at solving an exponential with a real world application. And we'll come back to the compound interest formula. Remember, it was A equals P times 1 plus R over N raised to the N times T. Okay, we can say, let's say Riker's about to have a birthday, right? So let's say Riker, for his birthday, winds up getting, oh man, let's say he gets $20. Oh, that's awesome. Okay, $20. And Riker's a smart kid, right? He's like, I'm not going to go spend it on all this cool stuff I want at Walmart. Oh man, Riker's got like a Christmas birthday. Man, it's a bummer, Riker. Okay, I'm not going to spend it all on this go to Walmart, spend all the money on fun toy stuff. I'm going to invest this thing. Okay. So he goes around and he knows that, you know what, he's got some video game he like. I don't know whatever Riker's into. I should ask Miss Megan what Riker was into. And but he knows that the thing that he's really into costs $80. Okay, maybe it's like a computer game, or I'm not sure what costs $80 anymore. I know my kids are 14 and 15, and it's all computer crap. Okay, stuff. I should watch my language. But so we're going to go about this a little differently. Riker got $20 for his birthday, but he wants to invest it to get it to $80 because what he's wanting to pay for costs $80. Okay, now he goes to the bank, and the bank says, we can put it in this, fund, and we'll get like awesome interest rate, like 11.5%. This is definitely not real. This is the Bank of Mom, maybe. Okay, 11.5%. And then they compound it. Let's say they compound it annually, because I don't think we did an example like that. And compounding it annually means that they only compound it once a year. And so now Riker wants to know, well, how old am I going to be when this thing actually gets to $80, right? So let's plug in what we know. We know A is 80 equals, we start with 20. 1 plus, now our rate, remember we've got to write our rate as a decimal. So it's going to be 0.115, right, because it's 11%, divided by 1, raised to the 1 times t. Now I'm going to rewrite this a little bit here. So it'd be 80 equals 20 times, 1.115 divided by 1 is just 0.15. So I'm going to add those together. So it'd be 1.115 raised to the t, right? Now, look, we solved this, and we'll know how many years. Remember, this is in years. It's going to take this 20 to turn into $80, okay? So if we want to solve this, it's an exponential equation. I'm going to use ln on both sides, but I've got to get the 20 to go away. Remember, I can't have a number out front. So this is 4 equals 1.115 to the t, right? I'm going to take the ln of both sides. To the t. And what that does is it brings the t out front, right? So we get ln of 4 equals t times ln of 1.115. Divide off the ln of 1.115. And we wind up with, let's see here, ln of 4 divided by ln 1.115. 12 years. Woo, buddy. So Riker would be like 18. Okay, Riker's going to be 18 when this thing finally matures to $80. Okay, to flip $20 into $80, it's going to take 12 years. And that's getting a really good interest rate, 11.5% interest rate. It seems like it should be quicker than that, but maybe I'm just, if I got that one wrong, let me know. I made that one up. So 11, 4, 11. It's gonna be 18. It's like, yes, finally got this Paw Patrol. It's fun. Throwback. I always wanted one of these. Okay, so let's look at the homework. Homework is going to be on page 489. Starts on page 489, and I want you to start with the beginning. So 1 through. You can do 1 through. Let's do 42. I guess 41. We'll do odd. 1 through 41, and then 49 through 71. Odd. And then let's choose, I think it's 103. The application stuff's the fun stuff. 103 through 119. And all of these are going to be odd. Okay? This is all odd. All odd. 1 through 41, 49 through 71, 103 through 119, all of that odd. So, okay. Let me, hold on. Get myself situated here. Hey, okay. So, tomorrow, which is Thursday, we're going to review for the test. I got my mask upside down, don't I? We're going to review for the test. It'll be, over 4, 2, 3, and 4. And then I'm going to open up the test for you to do until Tuesday. I think I've said that already, but I'm just saying it again. It doesn't hurt anything. Okay, so we're good to go. My